This video goes over how to graph parabolas with a vertical stretch and how to graph parabolas with a combination of transformations. So the first one, we're going to start off the same way that we did the horizontal and vertical shifts by graphing some parabolas with a table of values. So the first one here is our parent function or our base function, our regular parabola. We've got 4, 1, 0, 1, 4. We can plot that on our graph fairly easily. There's our first one. Our second parabola here now has a 2 in front of it. I'm going to do that one in red. So I've got 2x squared. So that means that I'm going to take my x value, square it, and then multiply it by 2. So I'm going to have 8, 2, 0, 2, and then 8. And now I'm going to plot that on my grid. So 1, 2, 2, 8, and then I've got on my left side, and then I can connect those dots. We notice that my value in front of the x squared was larger than 1, and my parabola is skinnier. The last one that I'm going to do here, I'll do in green. Now you notice I've got a fractional coefficient in front, so I'm going to take my x value, square it, and then divide by 2. So I'm going to get 2, 1/2, 0, 1/2, and 2, and then I can plot this on my grid. So I've got vertex stays the same, -1 and 1/2, the -2 and 2, 1 and 1/2, and then 2 and 2. Now you notice now my coefficient in front is less than 1 and my parabola is flatter. So in general, when we're graphing y equals ax squared, if a is greater than 1, the parabola is vertically stretched, or it's skinnier. If a is between 0 and 1, my parabola is vertically compressed. Which means that it is flatter. And if my a is less than 0, I'm going to have a reflection in the x-axis, which is a vertical reflection. So let's look at a chart that's going to state the basic properties of the following parabolas. Okay, and then we can check by graphing. We'll use Desmos for that. Okay, so in our first parabola here, we've got 2x squared plus 1. Now I know that my vertex, there's no horizontal shift, so my x-coordinate is 0. There is a vertical shift, so my y-coordinate is 1. My axis of symmetry is the x-coordinate of the vertex. My direction of opening is up because a is positive. And my minimum and my maximum value, I'm going to have a minimum, and my value is 1, the y-coordinate of my vertex. Let's look at another example here. So 3x squared minus 9. So again, no horizontal shift. I have a vertical shift down. My vertex is going to be 0 minus 9. My axis of symmetry is x equals 0. My direction of opening is up because my a value is positive. And then I'm going to have a minimum value. And that minimum value is going to be equal to -9, the y-coordinate of my vertex. My last example here, y equals -4x squared minus 6. So no horizontal shift. I do have a vertical shift down by -6. My axis of symmetry is still 0. My direction of opening now is down because my a value is negative. And now I'm going to have a maximum value equal to the y-coordinate of my vertex. Before we move on, I just want to go back here to the point pattern. If you remember, for y equals x squared, we are using 1, 3, 5. If you have y equals a x squared, your point pattern is now just a times 1, a times 3, and a times 5. So let's look at a couple of examples that are combining all the transformations that we've done so far. For each of the following, we're going to state the characteristics and then we're going to graph. So looking here at our first example, y equals 3 times x minus 4 squared plus 1. We're going to state the vertex, which is our horizontal shift, and then our vertical shift. Our axis of symmetry is always equal to the x-coordinate of the vertex. And our direction of opening is up because our a value here is positive. Because our parabola is opening up, we have a minimum, and our value is going to be equal to the y-coordinate of the vertex. So I can plot this by my vertex here, 4, 1. And I know that my a value is 3. So then my point pattern is going to be over 1 up 3, over 1 up 9, and then over 1 up 15. So I would go over 1, up 1, 2, 3 on both sides. From there I would then go over 1, 1, 2, 3, 5, and I can't fit those on my graph, so it's okay with just those 3 points. I just know that my parabola is going to be very skinny, going up like that. And I've got y equals 3, x minus 4 squared plus 1. Let's do a second example here. We've got y equals minus 1/2 x plus 2 squared minus 4. So my vertex, I'm going to pull out my x transformation and my y transformation. My axis of symmetry is the x-coordinate of the vertex. My direction of opening in this case is down because my a value is negative. Because my parabola is opening down, I'm going to have a maximum value, and that maximum value is going to be equal to the y-coordinate of my vertex. So now I can plot that one. I'll do it in red so it looks different on the graph. So I've got my vertex is minus 2, minus 4. And then to plot it quickly, I can use my point pattern. So instead of going 1, 3, 5, I'm going to multiply each of those values by my a value. So minus 1/2, minus 3/2, and then minus 5/2. So starting from my vertex, I'm going to go left 1, down 1/2, right 1, down 1/2. Then I'm going to go left 1 and down 1.5 on both sides. And then one more time, I'm going to go left 1 and down 5/2 or 2.5. So down here and down here, which is going to give me my other parabola. So y equals 1 minus 1/2 x plus 2 squared minus 4. And there are 2 examples of putting all the transformations together.